Good morning to all of you. So welcome to this 60 days targeted mission prelims batch. You see, first thing that you need to get into your heads is this examination is easy. It is not tough. What is required is just a strategy, and in these 60 days we will try to evolve that. Clear? But I will not be able to do it on my own. I need your participation in it as well. So are we good to go? Okay. So let us begin with our first section, and that is geography. You see, geography, this word is very new. It was not there for several centuries, because those who studied geography used to call themselves as earth scientists, or they would call themselves as any other name but geographers. It means geography is a very recent term. It has been coined by a Greek polymath. What do we mean by polymath? Polymath means, have you heard the name of Leonardo da Vinci? Yes. Was he a singer? A poet? He was everything. He was very suitable for UPSC. Very good in all the things. Clear? Polymath means, in the earlier days, there were no specialists, but there were generalists. A polymath was a generalist. And there was a polymath, his name Eratosthenes. Eratosthenes coined the word geography. Now, what does geography means? Geography means that it is the study of the surface features of the earth. Now, on the surface of the earth, if you see, there are two kinds of features. One which is created by nature, and second which is created by man. The study of the features created by nature became the subject matter for physical geography, whereas the features created by men, like agriculture, industries, etc., over the surface of the earth became the subject matter for human geography. In geography, we like to call it the study of physical landscape and the study of cultural landscape. Now, what is a landscape? A landscape is nothing but a mosaic of different landforms. And what are landforms? Landforms are like, say, mountains, plateaus, etc. Clear? But the word landscape and landform is more popular in physical geography. Whereas in cultural geography, we would say activities of man over the surface of the earth. Now you see, study of geography. In geography, do we study crust, mantle, core, etc.? It means we study the interior of the earth, but the study of interior of the earth is not geography, it is geology. Also, the study of earth as a component part of the universe is not geography, that's astronomy. Geography is the study of the surface of the earth. But to understand the surface, we must have some knowledge about the interior of the earth as well as the earth's atmosphere. Like, say, for example, if there is a mountain, the mountain grows due to forces that come from within the earth. We call them endogenetic forces. And as there is rainfall over that mountain, with time, the mountain erodes. And again, we get back to from where we started, a plane surface. And that is exogenetic downcutting. Now, the rainfall was engendered by the clouds, and the clouds were formed due to the evaporation caused by the sun. And sun is a part of the universe. So, to understand the surface of the earth, or to be more precise, the surface features of the earth, it is very essential to understand the interior of the earth as well as the earth's as a component part in the universe. Now you see, I'm saying that geography is the study of the surface of the earth. What kind of study? It's a spatial study. Spatial study means it deals with space, whereas temporal studies are which deals with time. History, for example, is a temporal science. That's why in history, or historians, they are always interested in building chronology of any event, whereas geographers like to build chorology. Chorology means it is the study of space. It means how things are arranged over the space. Can we study that how mountains are placed over the surface of the earth, how lakes are placed over the surface of the earth, which are the major rice producing areas. It means we can understand how human features or how physical features are arranged over the surface of the earth. The study of this arrangement is known as geography. The aim of geographers is to ultimately make a map. That's it. That where the things are and how the things came about in the place where they are at the moment. Now you see one thing, that geography is not like physics. Geography is also not like history. What do I mean by that? It means if you think about physics, now there are some laws in physics. Like one law would be, say, if I drop this duster, it will not fly, because that's the law of universal gravitation. It will happen with whatever object I drop. Even if I pick an elephant and drop it, it will also drop, because that's an absolute law. Physical sciences have absolute law. It means it will happen all the time. Whereas human sciences, or what we call as social sciences or humanities, does not always indicate that it will happen. Like say for example, if in the first battle of Panipat, it was fought between, the first battle of Panipat was fought between Babur and Abraham. Suppose Abraham Lodi would have won, or suppose Siraj-ud-Dowla would have given a thrashing to the East India Company, the course of history of this land would have been totally different. It means we cannot say that this will always happen in humanities, but in geography, or say in physics, especially with respect to the physical aspects of geography, we can say so. Like say for example, if I put some water in this glass and keep this in sun, will the water evaporate? Yes. Suppose it's a lake, will the water evaporate? It's a swimming pool, will the water evaporate? Yes. It means it will happen all the time. But suppose there is good rainfall and good temperature and conditions are ideal for growing rice. Can you say that the farmers will pick rice all the time? Not necessarily. Do you understand this? It means the human geography is more like humanities, where you cannot say, because it involves the behavior of man, which is very unpredictable. But physical geography is very much like physics. It's like pure science. It will happen. Do you understand this? If there is a low pressure area and it is created over tropical oceans, there will be a cyclone, provided that the low pressure area is not at the equator. Because at the equator there are no cyclones. Why? Because the Coriolis force is zero at the equator, and cyclones need Coriolis force. We'll understand all of that, but let us get started and see. This is the best picture I got of him. Eratosthenes of Cyrene. Cyrene is in Libya. It was known as the Athens of Africa. And you see, Eratosthenes, he's a Greek polymath, and I already explained what do we mean by a polymath. He coined the word geography. You see, geography is a spatial description, we understand that, of Earth's surface features, physical and human. And we're saying that it's a special science. Why? Because it is not totally like physics, it is not totally like history, or it is not totally like economics, it is not totally like mathematics. So it is somewhere in between, and that is the reason why geography was not included in university studies for several generations. Because if they created two shelves, one for humanities, one for pure sciences or natural sciences, they found it very difficult where to place geography. But ultimately you see that if you look at all the universities, at least in India, you will find that geography has been placed in the category of humanities. Clear? But remember, geography is a special science that deals with spatial description of Earth's surface. So far so good? Let's move ahead. So we will try to understand now some of the other basics, like the shape of the Earth. The shape of the Earth is not a perfect sphere, but it's a geoid. Now what do we mean by geoid? You see, if you look at the Earth is not perfectly spherical. Also, is the earth stationary or is it rotating? It is rotating. Now if you see that the earth rotates from west to east. Now some books would write anti-clockwise, clockwise, but this is not a good description because it rotates anti-clockwise when you look it from the north pole, but clockwise when you look it from the south pole. So better description would be the earth rotates from west to east, and anything that undergoes rotation, does it experience a force called centrifugal force? Yes, and due to this centrifugal force, it is a force acting away from the center. The earth is trying to go away from its own center. Can you understand this? And as a consequence of it, there is a bulge at the equator. And if there is a bulge at the equator, you can understand that the poles get flattened. Suppose I have a very soft ball, soft hollow ball, say a rubber soft hollow ball. And this is what I do. I put that ball in my hand, and if I squeeze it from top and down, what would happen in the middle? It will bulge. Do you understand this? So the earth is not a perfect sphere. You must keep this in mind. But it is more perfect than all other spheres that you see. Say for example, say think of a football or a basketball or a volleyball. The earth is a better sphere than these spheres. The irregularity from a true sphere with respect to earth is only 0.03%. So it is very close to a sphere. What do we mean by geoid? A geoid is an earth-like shape, or the earth is uniquely shaped earth-like. It means it has a bit of bulge at the equator and it is flattened at the poles. Are you clear with that? Now, in order to demarcate places on the earth or over the surface of the earth, geographers developed two tools, latitudes and longitudes. Now, what is latitude? Latitude is, see, for any measurement, I need one frame of reference. So the equator can be easily highlighted over the entire earth. So equator was taken as 0 degree latitude. Clear? And then the latitude for any other place was identified with respect to the equator. Say for example, the equator here is 0 degree, and suppose I want to know the latitude of this place. It means any place over the surface of the earth. And so what I need to do is, from that place, I need to draw a line to the center of the earth, which is shown here. And then from there, you can understand, suppose I'm looking for this place. So I have to do a line which will go right into the center of the earth. And from there, I have to measure the angle with respect to the equator, which I have already taken as 0 degree latitude. And suppose the angle here is 30 degree, so I'll call it 30 degree. One thing that you would see is all the latitudes are parallel to each other. Therefore, they are also known as parallels of latitude. Similarly, the latitudes which are placed north of the equator are northern latitudes, and the latitudes which are south of the equator are southern latitudes. And you can understand, suppose I'm finding the latitude at the pole and you see the angle is 90 degree, and therefore 90 degree north is your north pole. Clear? Similarly, if you have to find the longitude of a place, what you need to do is, again, you have to get one longitude as the frame of reference. But here emerges a point, because if you look at all the latitudes, the equator is clearly the winner because it's the largest one. But if you look at longitudes, all the longitudes are of same length. So it becomes very difficult to identify or to choose one. So it was decided that the longitude which was passing through Greenwich, where is Greenwich? It is in the Royal Observatory in London. So from where it is passing, that longitude will be taken as the frame of reference, and it was given the name as 0 degree longitude or the prime meridian. Clear? Now, you see, by taking the prime meridian, like suppose this one, as the frame of reference, and you can see that it's passing through Britain, and you see that with respect to this, again, we can draw a, suppose I want to know the longitude of this place, so what I need to do is I draw a line from this longitude to the center, and again to the place for which I want to find out the longitude, and I find the angle. Suppose it is 90 degree. Like with respect to latitude, we looked at north and south. With respect to longitude, we look at east and west. Since the earth is 360 degree, so if this is the prime meridian, we have 180 degree east and 180 degree west. It has to be noted here that 180 degree east and 180 degree west longitude are one and the same longitude. Are you clear with that? And all longitudes, if you see that 0 degree longitude or prime meridian is just opposite to 180 degree east and west. Are you clear with that? So look at this. So we understand that the shape of the earth is uniquely earth-like. It's a geoid. It's not a perfect sphere because of the centrifugal force. And we understand what is latitude and what is longitude. Unlike the latitudes, the longitudes are not parallel to each other because all of them meet at the poles, and their distance keep on increasing as they approach the equator. I can say the longitudes are never parallel to each other but at the equator. At the equator, all of them become parallel to each other. Now, let us see. There is one line written here which says, of all the latitudes, only equator is a great circle, while all the longitudes are semi-great circle. Now, what is a great circle? A great circle is the largest circle that can be drawn over a sphere. It's a geometrical concept. And how can we achieve a great circle? For that, you have to take one sphere, suppose in this case this globe. And what I need to do is I need to take a plane. Suppose this paper is actually, it is powerful enough to cut this globe. Suppose, imagine, or suppose I have the strength to do that. Just imagine like that. And suppose this is a plane. So I take this plane and I make it pass through the sphere at any angle. The angle does not matter. It can be any angle. But the point is that the sphere should be bisected by this plane. It means this plane should always pass through the center of the sphere. Do you understand this? Once I do that, irrespective of the angle, if I take a plane and I cut the sphere into two equal halves, then the points where the plane intersected with the sphere on its surface, if I join all those points, I get the largest circle that can be drawn over a sphere, and such a circle is known as the great circle. Now, simply put, a great circle is one, in very simple languages, a great circle is one which divides a sphere into two hemispheres. Do you understand this? And does the equator does that? Yes. So equator is a great circle. But what about Tropic of Cancer? It does not divide the earth into two equal halves or two hemispheres. That's why the Tropic of Cancer, Tropic of Capricorn, the Arctic Circle, Antarctic Circle, or any other latitude apart from the equator is not a great circle. The great circle is any circle which divides the earth into two equal hemispheres. Now I will draw some great circles or some circles. You would say that whether they are great circles or not. Now look here very carefully. Is this a great circle? Is this a great circle? No. What about this one? What about this one? Yes. So did you understand that? The angle does not matter. It is that the sphere should be divided into two equal halves. But if you look at all the latitudes, only equator does that. Northern hemisphere and southern hemisphere. Therefore, equator is a great circle. Whereas when you look at the longitudes, all the longitudes are semi-great circle because 0 degree is only 180 degree east-west when you extend it on the other side. Are you clear with that? So all the longitudes are semi-great circle. Now this can be a sentence for your preliminary examination if there is a very basic question with respect to the shape and size of earth. And it is not uncommon for UPSC to ask such silly questions. They have been asking and they will not stop. They will keep on asking such questions. Yes.
Exactly a great circle?
Yes.
Exactly.
Yes. If you see precisely, if you can measure it precisely, the point is you will not be able to look at it. If you look at it from a space, you will not be able to look at it because of the refraction and the reflection that keep on happening because of the surface features of the Earth. Now look at this. So this is a great circle. This is also a great circle, but these are not great circle. Now, if you look at this, it says the circle of illumination is a great circle. Now, what is this circle of illumination? Circle of illumination is nothing but the great circle over the surface of the Earth that separates the day from the night. Let's see. Suppose this is the sun, and you know at any given point in time only one half of the Earth is illuminated while the other half is dark. Now think of this. Suppose this half is illuminated whereas this half is dark. Then you can say that here you have a great circle which separates the day from the night as the Earth rotates from west to east. That's why the sun rises from the east. Are you clear with that? And you see that the circle of illumination is a great circle. It means it divides the Earth into two hemispheres, the sunlit hemisphere and the dark hemisphere. But also you have to keep in mind that the Earth is inclined at an angle of 66.5 with respect to its orbital plane. And this is the reason why that the circle of illumination does not bisect all the parallels. If it bisects all the parallels, then every parallel will have equal length of day and equal length of night throughout the year. But it does not happen so. Because of Earth's relative position with respect to sun as it orbits around the sun, we have different seasons. And this happens because of the axial inclination of the Earth. Okay, if it is the month of January, what is the inclination of the Earth with respect to its orbital plane? 66.5. In February? What about June? What about December? It means it remains like that throughout the year. This is known as axial parallelism. If there is no axial parallelism, there will be no seasons. So I don't think that line is written. You can write one line that axial parallelism is the reason for season. Axial parallelism is the reason for season. Okay, now look here. This is what I'm saying, that this is the circle of illumination. And since the Earth is inclined, if you see that not all latitudes, like this is the 21st June scenario, which we call as the summer solstice, you will see that the parallels lying north of the equator, greater portions of them lie in the sunlit hemisphere and lesser portions of them lie in the dark hemisphere, except at the equator, because the equator is equally divided. Whereas south of the equator, you would see that greater portions of the parallel lie in the dark hemisphere, whereas lesser portions of it lie in the sunlit hemisphere. And you understand that the Earth is not a circle but a sphere. So it is something like this. So you can understand as it rotates from west to east, for these areas, you can understand the Earth is like this. It comes out of the board and goes into the board, and it is rotating. Try to imagine that. And I'm saying that as it is rotating, spinning on its axis, inclined with respect to the orbital plane, you will see that, say, these parts, greater parts are in the day hemisphere and lesser parts are in the night hemisphere. That's why you have longer days, shorter nights. Longer days and shorter nights are a feature of which season? Summer season. So that's why we call this situation as the summer solstice. Whereas when you look at the Tropic of Capricorn, you'll see that it is longer night and shorter day. So it is winter for the southern hemisphere. Whenever it is summer for the northern hemisphere, it is winter for the southern hemisphere. Now look here. If you look at the equator you will see that it is equal day and equal night. Do you understand this? Now look here at the Arctic Circle. Can you see that as it rotates, the entire part is in the day hemisphere, whereas at the Antarctic Circle, the entire part is in the dark hemisphere. So on 21st of June, can I make one statement, and this can be a statement very well in your examination, that on 21st of June, the sun never sets at the Arctic Circle and never rises at the Antarctic Circle. And beyond it, it's only day, and beyond this, it's only night. Are you clear with that? Now this is the circle of illumination, and the circle of illumination is a great circle. You understand that? Now look here. It says that the circle of illumination is the division between day and night over the earth. The circle of illumination bisects all latitudes on the spring and autumnal equinoxes. At this time, all places have equal day length. The circle of illumination always bisects the equator, 0 degree latitude. Let us understand these lines. It says that if the circle of illumination bisects a latitude, bisects means divide it into two equal halves, then that latitude at that time will have equal day and equal night. The position when all the latitudes are bisected by the circle of illumination is known as the equinox position. Equinox means equal days and equal nights, and we'll understand that with the help of the next diagram. If you see this, that this is what is the scenario in 21st, 22nd of June, and this is the circle of illumination, and you can see that it's only day at the North Pole and only night at the South Pole. And you see the equator is bisected, but all other latitudes, because the sun rays are directly over the Tropic of Cancer, all the other latitudes north of the equator have longer days, shorter nights. South of the equator, longer nights, shorter day. This is summer solstice, though it is winter for southern hemisphere. But see, who cares about southern hemisphere? Because 90% of the humanity lives in the northern hemisphere, and that's why we are a bit biased towards the northern hemisphere. But if you see that this is winter, so June is winter for them. Whereas you see that the earth is not only rotating and inclined, but it is also revolving around the sun. So it should go like this, but we cannot show it here, that's why we are showing it here. And if it is like this, you can understand that the circle of illumination goes like this. Think of this. Suppose this is the June scenario, and this is, say, in 12 months it will complete one revolution. So in 3 months it should be here, 6, 9, 12. So think of this, that this is June, and imagine me to be the sun, and suppose this is where it is in September. If this is where it is at September, can you understand this is the great circle? If this is the great circle, the side that is facing you is night or day? Night. Can you understand this? And you see that the great circle is dividing all the latitudes in this scenario in equal halves. And that's why all places have equal length of the day and equal length of the night. And this is known as the equinox position. Whereas if you see, when it revolves and comes here on 21st, 22nd of December, the sun rays are directly over the Tropic of Capricorn. And because of this, if you see that the areas north of the equator have longer nights and shorter days, and areas south of the equator have longer days and shorter night. So this is winter solstice, because it is winter for the northern hemisphere, though for the southern hemisphere it is summer. Christmas, by the way, is celebrated in Australia in summers, and Australia is now experiencing summers because we are experiencing winter. And then you have the other equinox, and if it comes on this side, you can understand now you are seeing the sunlit side, whereas the dark side is hidden from you. So all the latitudes are again equally divided, and you can understand the earth is, it comes out of the board and goes into the board, and you can understand that since all the places are equally divided, all the latitudes are equally divided, every place has equal day, equal night. That's the scenario which happens on 21st, 22nd of March, very much similar to what happens on 22nd, 23rd of September. These two time periods are known as equinoxes. So this is what the previous slide told us. It said that the circle of illumination bisects all latitudes on spring and autumnal equinox, because March is spring and September is autumn. Though in India we do not experience these seasons because ours is a tropical land and we have more monsoonal influenced climate. That we'll understand when we go to climatology. Now you see that at this time all places have equal day length. The circle of illumination always bisects the equator. It means that when you look at, say, summer solstice, is the equator equally divided? What about equinox? All latitudes are, so equator cannot be an exception. Winter solstice? What about the spring equinox? Yes. So throughout the year, if you see, equator has equal day and equal night. That's why you will see books writing that the season is a meaningless term at the equator. Because for seasons, you must have some variation in day length and night's length. Suppose there is no axial parallelism, or the axis is not inclined at, say, 66.5, it is something like this, then you can understand that throughout the year, every place will have equal day and equal night. And if every place has equal day and equal night, no place will have a season. Because if every day is similar to any other day, you cannot highlight the contrast between days, so there is no season. So axial parallelism is the reason for season. Do you understand this? So let's move forward. Let us see a few things. If you look here, it says that season is a meaningless term at the equator, whereas the maximum contrast is seen at the poles, because the poles is what sees 6 months daylight and 6 months night time. Now let us look at this, local time and standard time. Now what is local time? Local time means as the earth is revolving on its axis, you can understand that there will come a time when a place which is located on a particular longitude is directly under the sun rays. Can you understand this? It means the sun is highest in the sky at that point with respect to that longitude. But you must understand this, that at noon, where is the sun? It's overhead. Can we say so? So sun is overhead at noon, but it happens only within the tropics. It never happens beyond the tropics. And why does that happen? If you see, look here, saying suppose this are the sun rays, and think of this, that suppose this is the earth. If you see, as we approach from the equator, suppose just for the sake, I'm not considering the axial inclination, just for explaining this thing more simply. If you see that if you look at the equator, the angle made by the sun rays are 90 degree. Whereas when you look at higher latitudes, and you would measure the angle by drawing a tangent to the surface of the sphere, and if you see that the angle gets reduced, and at the poles maybe it is almost 0 degree. So if you are standing at the North Pole, the sun will be below your knees. Do you understand this? Whereas if you are standing at the equator, because if you are standing in the North Pole, you will stand like this. If you are standing in the South Pole, you will stand like this. And if you are at the equator, you will stand like this. The sun is overhead you. The time when the sun is so in the equator, or at the equator rather, this is how the sun will move. Say suppose this is your east, it goes like this. Noon time, and then sun sets. But if you are at the poles, it will go like this. Can you understand this? Because it is never overhead. The sun rays become more and more oblique as you approach the poles. Are you understanding this? Now what is this local time and standard time? Local time is identified with the help of the sun rays. The time of the day when the sun is at the highest point in the sky for a particular given longitude, that time becomes its noon time. It means you just look at the height of the sun whenever it is at the highest point in the sky, you match your clock to, or your watch to 12 o'clock in the noon, and thereafter you have all the times. But you see, say for example Arunachal Pradesh and say for example Gujarat, and you can understand sun would be overhead at different times in these two places, but still we follow the same time. If you just ask a friend in Arunachal Pradesh that I will give you a call at 10 a.m. and if you call at 10 a.m. by looking at your watch, his watch will also read 10 a.m. But at that time it is not necessary that the sun is overhead at the longitude in which you are or in which he is. Maybe they are not at their highest points at that time. Why? Because you have accepted a standard meridian. Meridians are nothing but the longitudes. You have accepted a standard meridian as the frame of reference for measuring time for the entire region. Say for example in India, which is the standard meridian? 82 and half. It means 82 and half degree east longitude. East longitude's local time is our standard time. Do you understand this? And why do we do this? Just to avoid confusion. Because if everyone has local time, and if suppose you say I'll give you a call at 10 a.m., maybe who is living east to you will be ahead in time, and who is west to you will be behind in time. And if suppose, forget about a phone call, think about UPSC preliminary examination. Everybody will reach the center at different times, and that's why you have a standard time. Let us look at the difference. It refers to the time of a particular country or place. That is local time. It mostly with respect to your prime or central meridian for that region. It depends on the movements of the sun. I already explained that. It changes due to the shift in the longitude, and I already explained that. Now you see, standard time, it refers to the official time of a region consisting of several countries. Say many times when we say standard time, we refer to the Greenwich Mean Time, because the local time of the prime meridian, which passes through the Royal Observatory located at Greenwich, is considered as the standard time for the entire world. Are you clear with that? And it depends on the law made in a country, because some countries have more than one standard times, some countries have less than one. Anyhow, it remains constant in the country. You see, GMT is the mean solar time at the Royal Observatory in Greenwich, London, reckoned from midnight. It means 12 o'clock. Now, Indian Standard Time, if you look at this, Indian Standard Time is the time zone observed throughout India. With a time offset of GMT, we are to the east of London, and we are ahead by 5 hours, 30 minutes. Now, if I divide the entire Earth into time zones, I can divide it into 24 time zones of 1 hour each. Do you understand this? 12 time zones to the east of the Greenwich, 12 time zones to the west of the Greenwich, because in 24 hours you complete one rotation. It is now accepted practice among different countries to take their standard time in multiples of 7 degree 30 minutes. It means 30 minutes per time, because 1 hour time zone will have 15 degrees, because if the Earth completes 360 degrees in 24 hours, then 1 hour it will move by 15 degree. Do you understand it? 30 minutes it will move by 7 degree 30 minutes. So 7 degree 30 minutes is what is the referential frame for us now. Now you see this, countries with huge longitudinal expanse have more than one standard time. Now look at this, UPSC can play with such words that countries with huge latitudinal expanse will have more than one standard time. It is not necessary. Only when you have more longitudinal expanse. Which country has the largest number of time zones? Russia? France? China. Achha, how many for India? But there is a growing demand that India should have 2 time zones. Clear? Okay, how many for USA? USA has? Okay, which country has the highest one? How many?
11.
France has 12. Why? Because we include the French territories overseas. Keep this in mind. France has more time zones than any other country in the world. Russia has 11. USA has 4. But the 5th one is with respect to it's the Hawaiian Islands and all those kind of things. Let us look here. This is the Indian Standard Time Zone. At times UPSC asks questions like, the IST passes through which state? ऐसे भी पूछ चुके हैं वो. So you keep this in mind. How many states? Uttar Pradesh, Chhattisgarh, Odisha and Andhra Pradesh. So keep this in mind that it passes through. Similarly, also look at how many states the equator, the Tropic of Cancer passes through. Now look at this. Now, look at this. Maybe the projector is not set properly. But at least we can read this. You see that US has 4 standard time zones. In addition, Alaska, Hawaii and 5 US dependencies all have their own time zones. Clear? As neither Hawaii nor 5 dependencies use daylight saving time. We'll discuss about that concept in a bit. Russia has 11. China follows how many? China has huge longitudinal expanse, yes or no? Is it greater than that of India? Yes. How many time zones should China follow ideally? At least more than 1. But you see, China is China. It follows only 1 time zone. Clear? There have been a demand that you should follow more than 1 time zone. So if suppose someone says you are living in the west, extreme west of China, and someone in the east says that 8 o'clock, or suppose China declares its civil services examinations at 8 a.m. in the morning, then someone who is living in the west actually goes to the examination hall when it is pitch dark. Do you understand this? Because China is China. Anyhow, we doubt that whether they conduct the administrative services examination or not. Now, look here. France uses 12 different time zones, more than any other country in the world. Daylight saving time is observed in metropolitan France from the last Sunday in March. Now, what is this daylight time? If you see that as we move to higher latitudes, you see that the sun rays become more and more oblique. As the sun rays become more and more oblique, you can understand that there is a greater refraction and reflection as you move to higher latitudes. What do we mean by that? It means, suppose if I hold a ray of light very steep, all the light would be concentrated at one point. But if I reduce the angle, it means from 90 degree, if I reduce it to say 45, can I say the light would be spread to a larger area? If I hold it 0 degree, it would be spread to the entire room. Are you understanding this? Why does, as it spreads, it travels a more distance? As it travels a more distance, there is more scattering, more reflection, more refraction. And so the scattered light, it remains for some time. It means, very simply put, if you look at the equator has equal day, equal night throughout the year. It means 12 hours day, 12 hours night throughout the year. But at the poles it is 6 months day, 6 months night. So, depending upon which solstice we are in, can we say this, that during the summertime, at least for the northern hemisphere, if you see that if you move north of the equator, the days become longer and the nights become shorter. So suppose the days in the summer season, the days would be longer in India or in UK. it is summer solstice. Days would be longer in India or in UK? UK or Sweden? Because Sweden is located more north. Sweden part of Scandinavia. Do you understand this? It means, think of summer season. When does the sun sets? Suppose May, late May or 7. In London it should be in the summers. The days are longer. So if in India the sun sets at 7 o'clock, suppose just for hypothetically, it should be in London more than 7? Maybe at 8. Do you understand this? In fact, the sun sets here in some time of the year at 7:30. Have you noticed it? And it remains daylight in London up to 9. Can you understand this? So it means that the day starts very early and the day ends late. Do you understand this? So it means if your clock or if your watch is reading, say 8 a.m., the sunrise has already taken place very early. Suppose it's 6 a.m., the sunrise is already taken place because say the length of the day is 16 hours and night is only 8 hours. And if this is the situation, you see what people do in higher latitudes, especially in the temperate area. This has been a practice, though it was started by some Germans, and there is also indication that the Greeks did it to some extent, but this is very doubtful. Its modern day credit should go to New Zealand, because New Zealand for the first time propounded this idea. But now almost all the countries located in the mid latitudes follow this, because at very high latitude there is no humankind. At the poles there is no humankind. At the temperate latitudes you see that people follow this idea of daylight saving. What does this daylight saving means? That before the approach of the summer, they just move their watches 1 hour ahead so that they can utilize more daytime and thereby lessen the consumption of fossil fuels. Do you understand this? Because you understand that when it is night time, you are using electricity, and electricity is generated, a lot of electricity is generated by burning of coal, and therefore to reduce the consumption of fossil fuels, you increase your clock, or if you increase your watch reading by 1 hour. But when it is say just the winters are approaching, they go back to their original timing. The summers, when they move the clocks ahead or the watches ahead, this is known as spring forward, because spring is just the season before the entry of the summer. And autumn is also known as the season of fall, because आपने ये सुना है पतझड़? It happens during autumn. So that's why we call this as the season of fall. In the fall, they revert their watches back, and this is known as fall back. Are you understanding this? Let us see this. This is what they do, that in the spring they move their watches 1 hour ahead, and in the autumn they move their watches 1 hour behind. It means there is at least one day, this you have to keep in mind, there is at least one day in spring which is of 23 hours, and there is at least one day in autumn which is of 25 hours. Do you understand this? All the other days are of 24 hours. Clear? Now if you look at this, that this is daylight saving time, let's read this. DST, also daylight savings time or daytime in Europe, it is known as summer time, is the practice of advancing clocks during summer months so that darkness falls later each day according to the clock and not according to the movement of the sun. A common implementation of the DST is to set clocks forward by 1 hour in spring, known as spring forward, and fall back during autumn. In other words, there is one 23-hour day in late winter or early spring, and one 25-hour day in the fall. This is what you have to keep in mind. So if there is a statement which says that all the countries which uses daylight saving time have at least 2 days which are not of 24 hours. Is it a correct statement? Yes. That is what UPSC can go best for. Don't worry about it. Now, let us look at this, the international dateline. As the Earth is rotating on its axis, you can understand that half of it is day and half of it is night. So one place, think of this. Is it visible to everyone? Now, look here. I'm saying as the Earth is rotating on its axis, you see, suppose this is the circle of illumination. Can you understand this? And if this is the situation, suppose the sun rays are directly over the Tropic of Cancer, what time is it? It is, when the sun rays are directly over the Tropic of Cancer, it is summer solstice. So imagine this is summer solstice and this is how it is. Now as it rotates from west to east, you can understand every place will experience sunrise in the east and then it will go like sunset. When it enters the dark hemisphere, it becomes sunset. When it comes into the sunlit hemisphere, it becomes sunrise. And one sunrise and sunset makes one day. But if we go by the watch, it is from 12 to 12. That makes one day. 12 a.m. we say is morning. 3 a.m. in the morning. But is it really morning? No, it is not. It is morning only with respect to the clock or with respect to the watch. Are you clear with that? So, say for example, if it is 12 a.m. or suppose it is 11 a.m. in London, or let us be, say for example, imagine it is 11 p.m. in London. What would be the time in India? 11 p.m. in London. Suppose it is 11 p.m. Monday. 4:30 a.m. Tuesday. Do you understand this? It means the calendar has ticked over. Are you understanding this? Now think of this, that the prime meridian which passes through the Royal Observatory, that is the local time. Its local time is the standard time for the world. The meridian which is exactly opposite to it means the 180-degree east and 180-degree west meridian, has been chosen as the international date line, because if suppose this is 12 p.m. at GMT, then 180-degree east, 180-degree west will have 12 a.m. But if it's 12 a.m., the calendar has ticked over. Can you understand this? It means on this side you have, suppose this is 12 p.m. Monday. So on this side you have, if you go by 15 degree to the west of it, you will find 11 a.m. Monday. Then 15 more degree, then you have 10 a.m. So if you move by 12, you go to 12 a.m. Monday. 12 a.m. Monday at 180-degree west. Do you understand this? Now if you go ahead, you will see it is 1 p.m. Monday, 2 p.m. Monday, 3 p.m. Monday, and then you would have 11 p.m. Monday, and at 180-degree east you would have 12 a.m. because if it is 12 in the midnight, it is a.m. 12 a.m. But will it be Monday? Tuesday. It means 180-degree east and 180-degree west, both clocks will show 12 a.m. but the date will be different. Therefore, this line is known as the international date line. Are you clear with that? Because on its either side, the date changes. But what you have to keep in mind, that the ideal on the international date line is not a straight line, but it is a zigzag line. Why is it a zigzag line? Because suppose it passes through the middle of some land. Half of the land will experience some other day and half of the land will experience some other day. So if it says 31st of May 2020 is the UPSC preliminary examination, half of the people would be experiencing say 1st of June. वो तो बोलेंगे हो गया. Do you understand this? Whereas others might say that it is only 30th of May. That's why this is known as the international date line. Now look at this. It means, imagine this to be the prime meridian. So I'm saying that this is the international date line. Can you understand this? So this is west and this is east of it. Now look here. This is what we are trying to show. It means that suppose here this is the IDL. If you cross it from west to east, suppose one who was in 180-degree east in our example was experiencing 12 a.m. Tuesday. If he just crosses over to the west, it becomes 12 a.m. Monday. But he has already lived Monday. So he is reliving Monday. So he gains a day. Do you understand this? But someone who is at 12 a.m. on the western side moves to the eastern side. Do you understand this? It means someone who was already there at 180 degree or say 179 degree west moves to 179 degree east. Then for him it is from 12 a.m. Sunday to directly 12 a.m. Tuesday. Where is the Monday? He has lost the day. Do you understand this? So as we cross from west to east, this is west, your west to east, we gain a day. But if we cross from east to west, we lose a day. Do you understand this? Now, that is all about the basics. Let us now move to the factors that affect landforms. If you see that all landforms, they are nothing but an expression between two kinds of forces. The forces that emanate from the interior of the earth and the forces that emanate from the earth's atmosphere. Forces that emanate from the interior of the earth are known as endogenetic forces, and forces that emanate from the earth's atmosphere are known as exogenetic forces. Now if you see, suppose this is a landform, the endogenetic forces cause the creation of landforms. Now it can be an elevated creation, it can be a depressed creation, but it is creation of landform. Whereas exogenetic forces, which are nothing but erosional forces, they destroy the landforms and they level it back again, or if it's a depressed one, they fill it with depositions and they level the ground once again. So that is what we understand by the factors affecting landforms. The factors are of two types, endogenetic and exogenetic. Endogenetic can be divided into two types, diastrophic and sudden movements. Diastrophic landforms are or diastrophic forces are those forces that create the landform over a length of time. It takes say thousands of years. So much is the length of the time that humankind cannot appreciate the changes brought about by these forces during his lifetime. Are you clear with that? Whereas sudden forces are those forces which bring about the changes very quickly. Say for example, if there is a volcanic eruption, maybe the material that is ejected, the lava, it can get accumulated and there can be a volcanic cone formation. Are you understanding this? So the endogenetic forces are those forces which create landform, and they are of two types, diastrophic and sudden. Sudden are also at times known as catastrophic because of the destruction that they cause. Earthquakes, volcanoes, can they cause destruction? Yes. Now, diastrophic forces are also of two types, epirogenetic and orogenetic. Epirogenetic forces are those which build continents. It means suppose the entire continent is rising, that would be epirogenetic upliftment. Whereas if mountains are formed, they are known as orogenetic because the word orogenesis means mountain building. Now, epirogenetic can be of two types. I already told you that they can be elevated features or they can be depressed features. These forces are radial forces because they move vertical with respect to the surface. Now, if you see this, the earth is a sphere. The earth is a sphere, and you see that the forces that move from the interior, they move like this, and the direction could be either towards the center or outwards from the center. Can I say these are radial forces? If it is outwards from the center, it will uplift a landform. If it is towards the center, it will create a depression. Can you understand this? These forces are radial forces, or these forces are called epirogenetic forces. Clear? They are not vertical, because Earth is a sphere and radius is a good term to use for it. Similarly, there are forces which move like this and forces which move like this on the surface. It means towards each other and away from each other. These forces are horizontal forces, or rather, if it's a sphere, we will call them tangential forces. Are you clear with that? Now you see that when the forces that are tangential, they move towards each other, they create compression, and compression creates folding. If they move away from each other, they create tension, and tension creates cracking. Clear? So orogenetic or mountain building is due to tension or compression, whereas epirogenetic can be upward and downward. Similarly, let us come to these, because this we will deal today. Exogenetic forces. Exogenetic forces are destroyers of landform. You can write one line, right? Endogenetic forces are builders, exogenetic forces are destroyers. Endogenetic forces are builders, exogenetic forces are destroyers. Now, look here. Weathering and erosion. What is weathering? Weathering is the mechanical breaking up or the chemical decomposition of the rocks. That is weathering. Weathering is of actually two kinds, and the third kind is just added for the sake of addition. What do I mean by that? Physical weathering means weathering brought about by the mechanical processes. Like, say for example, during summer season, as the sun bakes the stone, it grows in volume, because anything that absorbs energy grows in volume. But during the night time, it releases the heat and it shrinks. And the stone is a very bad conductor of heat. It means when the sun rays strike the stone, it is only the topmost surface that grows and topmost surface that shrinks, because the heat is not transferred by conduction. Conduction, you know, when two bodies of different temperature come in contact with each other, heat flows from hotter body to colder body until both the bodies attain same temperature. But you see that because the rocks are bad conductor, they do not transfer the heat as much. So the topmost surface, it keeps on growing and keeps on shrinking. During the day it grows, during the night it shrinks, and it keeps on happening like that, and finally it crumbles and it falls apart. Do you understand this? With time, the rock will become smaller and smaller in size. It is as if you are peeling an onion. Are you clear with that? This is known as exfoliation or onion peeling. It's an effect caused by weathering. What is chemical weathering? Chemical weathering is, suppose there is rainfall over the rock and there are some minerals in the rock which can be dissolved in rainwater. So they would be taken away and the rock would be something like this. Or there are minerals which become or react in a certain way when hydrated. It means there are some chemical changes that are brought in the rock. Weathering can be physical, it can be chemical. It can also be biological. It means, suppose some animals can create burrows and break the rocks, but that is more or less mechanical weathering. And they can also release some enzymes which can react with the rocks and cause some changes in the rocks chemically. So weathering is, in simple words, it is the mechanical disintegration or the chemical decomposition of the rocks. Now listen one thing. Weathering assists erosion, but weathering is not necessary for erosion. You can write one line. Weathering assists erosion, but weathering is not necessary. Weathering, it is not necessary for erosion. Did you get that? Okay. Now, let us understand what is erosion. Erosion is the removal of the weathered material or the removal of the material which has been taken away, because materials can be taken away without weathering as well. Do you understand this? Erosion is the removal of those material, transportation is the taking away of those materials, and deposition is the piling over of such material elsewhere. Are you clear with that? The better names are degradation, transportation, and aggradation. And that's why you would see at times UPSC using degradational landforms, aggradational landforms, etc. Have you heard a term called denudation? Denudation is nothing but weathering plus erosion. Do you understand this? You can write this. Denudation equals to weathering plus erosion. Now you see, there are 5 major agents that cause erosion. They are running water. And running water, the best example of running water is river. That's why we call this fluvial erosion, because fluve is a term used for river. Then there is glacier, and we call it glacial erosion. Then you have sea waves, and we call it marine erosion. And marine erosion happens at the coastal areas. Can you understand this? Then you have wind, and we call this aeolian. Aeolian. A-E-O-L-I-N. Aeolian erosion caused by wind. And then you have underground water. Clear? Underground water, we call it karst erosion. Karst after the name of that region where it happens a lot. It is located in erstwhile Yugoslavia. Clear? The karst region, which is made up of limestone, and limestone, you know, they are susceptible to sinking of water, because water can dissolve limestones and can create holes over limestone, and thus water can seep in and can flow as underground. That's why they are known as karst erosion. Clear? These 5 agents of erosion are also known as geomorphic agents. Clear? You write one line. The agents of erosion are also known as geomorphic agents. The agents of erosion are also known as geomorphic agents. Clear? So do you understand endogenetic forces, exogenetic forces, diastrophic? Certain forces we are yet to understand them in detail. Weathering and erosion. Do you understand what do we mean by degradation? Do you understand what do we mean by denudation? Yes. Now, often a term is used in geography which is known as denudation chronology. Denudation chronology is, say, something like this. Suppose there is a mountain, and this is suppose 20,000 years before present ago. There was a mountain, and over this suppose there was rainfall, and rainfall, suppose hypothetically assume, happened for 20,000 years without being a year which is no rainfall year. Clear? So can I say that with time this mountain would get eroded? Can you understand this? And suppose because the rainwater will cause some flows across all the slopes, and thus the mountain would go lower and lower with time, and ultimately it would become almost parallel. Can you understand this? Now suppose this is present. What is denudation chronology? Chronology means arrange it with respect to time. Suppose this is say 10,000 years, this is say 500, this is say 20 years, and this is present. Denudation chronology is to trace back time and reconstruct the landform. Do you understand this? Write one line. Denudation chronology. Denudation chronology is the reconstruction of a denuded landform. Reconstruction of a denuded landform. But you see, this term has fallen out of fashion. Now we use evolution of landforms. Should I? It is an outdated term. It is an outdated term and has been replaced by evolution of landforms. Evolution of landforms. Okay, now let us see that what does, think of this, what does tensional stress does. Suppose there is a landform and it has some cracks. Imagine, suppose the cracks are like this, and this would be tensional forces going away from each other. Compression would be moving towards each other. And suppose if these are three blocks A, B and C, if I pull apart A and C, what would happen to B? It would sink. Do you understand this? Such sinking is known as faulting. When the Indian plate was moving towards the Eurasian plate, the western flank of the Indian plate experienced such sinking due to faulting. Do you understand this? And you see, as it falls, if I can show this, imagine something like this. Something like this. Suppose this was the fault line and this block has sunk beneath, then new surface would be exposed. Yes. This is known as the fault scarp. Do you understand this? And Western Ghats, suppose this is the plateau and a part of the plateau, western part, it sunk. So a scarp was exposed. These scarps are the Ghats. Are you clear with that? They are also known as, therefore, western escarpments. Clear? Write one line. The Western Ghats are fault scarps. The Western Ghats are fault scarps. Fault scarp known as western escarpments. Known as western escarpments. See, the Western Ghats, many people think they are mountains. They are not mountains, because suppose this is the plateau and a part of the plateau has sunk. If you look it from this side, it is not a mountain. But when you look it from the coastal plains, it is a mountain. That's why we do not say Western mountain, coastal. We say Western Ghat. Because if you see that this is how a ghat is, and you have the water. Have you heard about some major ghats in Varanasi and all? So if you see, this is how a ghat is, and Western Ghat looks very much similar to that. Because of this sinking of the western flank of the Indian peninsula, the sea water inundated some portions of the sunk Indian plate, and this is the reason why the continental shelf on the western side is broader than the eastern side. Clear? So, right? Is it clear to everyone? No. See, look here. As the western flank, it encountered some faulting, the sea water inundated a part of it, and that's why the western continental shelf is broader than the eastern continental shelf in the peninsula, because the east has not experienced any of such faulting. So you write one line. The western continental shelf of India is broader than the eastern continental shelf because of the faulting of because of the faulting of the western flank, FLANK means side, western flank of the Indian peninsular plate, when it was moving towards the Eurasian plate. It was moving towards the Eurasian plate. Now, if you see, look here, if you see the eastern coast and the western coast, I'm saying here you have experienced some faulting, and thus a part of the continent is now drowned under the ocean, and that's why you have a broader continental shelf. In the east, you have many rivers, and these rivers have formed deltas like the Mahanadi Delta, the Krishna, Godavari, Kaveri, etc. And suppose this is what I'm saying. This is the continental shelf, this is the slope, this is the plain, and this is the mean sea level. Imagine if there is a river which is bringing in a lot of sediments. Can you understand that it would make the shelf more shallower? Can you understand this? And this is what would happen. The sediments would get accumulated like this. And if suppose you are on the ocean floor, so it is impossible to go there, but suppose you are there and you are walking and you are climbing towards the continent, are you emerging or are you submerging? That's why the eastern coasts are known as emergent coasts, whereas the western coasts are submergent coasts because of the faulting. Let us write this too. So, right, the eastern coasts are emergent coasts, while the western coasts are submergent coasts. Okay, let's come back to this. If I apply tension on blocks A and C, they will sink. It's like putting one book between two books. If I keep those two books apart, the center one will go down, crushing, provided there is space. And you see that as it sinks, this is how it would look like. Can you understand this? These are the fault lines or the weak zones. You have an elevated block and you have depressed block. This elevated block is known as horst, whereas this one is known as graben. Clear? And this topography is known as horst and graben topography. If it happens at huge geographical scale, these horsts become your block mountains and the graben becomes your rift valley. Clear? And the same thing has happened in Vindhyas, Satpuras and the Narmada Rift Valley. Or you think of Mount Mitumba, Mount Michunga and the great African Rift Valley. Clear? Now, think of this. If it is a rift valley and that part is occupied by a river, it means the channel has not been created by the river but has been gifted to the river. And so the river that is flowing in it will be less muddy because it has not carved its channel for itself. No wonder the Narmada water is the clearest water of all the natural waters when compared to any other river. Do you understand this? Now, you see, if you see all the rivers, major rivers, they are flowing towards the east and falling in the Bay of Bengal, but Narmada flows towards the west along with Tapi. And why is this? Because it has not created its channel, rather it has been gifted. So as this happened, you can understand. Think of this. Why the Indian plate is tilted towards the east? Have you ever asked yourself this question? Now to understand this, think of this. Suppose there is a ship. There is a ship and the ship cracks. Suppose the ship cracks. Now as the ship cracks, it will sink. Can you understand this? As it sinks, you can understand, it would sink and go like this. Can you understand this? So as the western flank faulted, it went like this. The eastern part or the remnant of the plateau, it moved like this. but below the crust there is no water, so it cannot go like this crushing down, so it just went like this. Do you understand this? And that's why all the rivers are flowing now to the east, but there has been a faulting in between, and this faulting, this is how it is. Suppose this is what it happened, but imagine my fingers to go like this. Can you understand this? Because of this faulting, the rivers are now flowing to the west, Narmada and Tapi. And Narmada and Tapi do not form a delta. Why? Because they do not have sediments. Why don't they have sediments? Because they are flowing in a rift valley. This was asked by UPSC. That Narmada do not forms a delta. Why? The answer was very simple. It flows through a rift valley. So you write one line. Rivers that flow through the rift valley do not make delta. Rivers that flow through the rift valley do not make delta. But is it possible for any river flowing in the rift valley to make a delta? Is it possible under any circumstances? Yes. If there is large scale deforestation, then the river will be silted and it can carry the load and form a delta. Clear? So you write this line too. A river flowing in rift valley may also form a delta. The key word here is may. A river flowing in the rift valley may also form a delta if it is silted on a large scale. If it is silted on a large scale. If you look at the Indian plateau, it is made up of hard rocks. As it is made up of hard rocks, it is difficult to erode, and that's why the tributaries of Narmada, if any, short ones, they do not bring any sediments. Clear? This is also a reason why Narmada does not form a delta. See, right? Narmada flows through the crystalline rocks. Narmada flows through the crystalline rocks of the peninsular plateau. Crystalline rocks of the peninsular plateau, and hence do not carry enough sediments. Do not carry enough sediments. But if there is one reason why Narmada does not form a delta, it has to be its flowage through a rift valley. Clear? So are you clear with these forces? Yes.
Sir, this western escarpment, is it assisted by collision of compressional stress? Like because it collides, that's why, and mainly faulting is due to tension.
No, some scholars feel that as it collided with the Eurasian plate, due to the reverse jerk, this happened. But some others feel that as the Indian plate was moving towards the Eurasian plate, it happened en route, somewhere in between. Do you understand this? We are not very much clear, and UPSC will not bother you with such unclear kind of concepts. Clear? Okay. Now let us see this. So we understand what is a fault scarp. We understand what is Horst and Graben. Clear? This is a normal fault. A normal fault is caused due to tension, whereas a reverse fault is one which is caused due to compression. To understand this, look here. Think of this, that if you have a rock block which is like this, and these are the fault planes A, B, C, and suppose I apply tension on both sides. Will I say, can I say that both of them will climb? Both of these will climb? Both these sides will climb? And this is also faulting. But here the faulting is happening in a different way due to compression. Just remember one thing. If the faulting happens due to tension, it is normal fault. If it is happening due to compression, it is reverse fault. Compression, we told, cause folding of the crust, whereas tension causes cracking of the crust. Now think of this. Suppose if I apply compression, you have a fold, but if I apply tension, it will crack down. Don't do that. ऐसा नहीं है कि अरे अब क्या हो तो गया, सब कुछ फेंक दो. You should read this as you go to your places. Now you see that I'm saying that tension always causes cracking, whereas compression causes folding. But to what extent anything would be folded depends upon its elasticity. Isn't that so? Now think of this. If I apply compression, compression means forces moving towards each other. So if I apply compression to this, it will fold to a bit because it does not have a good elasticity. What would happen? It would break. So extreme compression can also cause cracking, and cracking is faulting. Such faults are known as reverse faults. Should you write? Just write one line, normal fault, put a equal to and write tension, semicolon, reverse fault equal to compression. Normal fault, tension, reverse fault, compression. Let us now move to folding. If you see, folding, I already explained that it happens due to the compressive forces, but extreme compression can cause faulting. Do you understand this? Now, if anything gets folded, what is a fold? A fold is a wave-like structure. It has a crest and a trough. So it has an upfolded part and it has a downfolded part. The upfolded part is known as anticline. The downfolded part is known as syncline. Clear? And you see that every anticline will have a syncline. Can you understand this? Because if you have an anticline, and suppose it's a continuous rock bed, if you have folding, then the moment you get an anticline, you will have a syncline adjacent to it. Are you clear with that? Now, think of this, that an anticline is the upfolded part, where a downfolded part is syncline. When this downfolding takes place at huge geographical scale, it is known as geosyncline. Like the Tethys geosyncline, out of whose sediments the Himalayas were formed. Are you clear with that? Now, the crest of the fold is the highest point. The trough is the lowest point. The two sides of the fold is known as the limb of the fold. If a limb is shared between an anticline and a syncline, it is known as mid-limb. Clear? And you see that the imaginary plane that bisects a fold is known as the axis of the fold, or the axial plane. Are you clear with that? Now, Himalayas are fold mountains. It means they are created due to compression. As the Indian plate collided with the Eurasian plate, they're moving towards each other. But imagine if this compression keeps on continuing, there will come a time when it will overcome the elasticity of the rocks and the Himalayas will break. And when it breaks, it would be utter chaos. You can understand this? Write somewhere one line. There is a possibility, don't worry about it, it will happen millions of years from now. There is a possibility that the Himalayas may crack or experience faulting on a large scale. On a large scale in the geological future. In the geological future. So if suppose I am moving through the Himalayas, will I see some folds? Yes? Will I see some anticlines? Will I see some synclines? Will I see some faults? Yes. Do you understand this? बस यहीं पर UPSC आपको फंसा सकता है और कहीं नहीं. Clear? So always remember that Himalayas also have some small scale faults, but folding dominates that place. Now let us move to this continental drift theory, which was given by Alfred Wegener. Alfred Wegener, he was a meteorologist and climatologist, a German who was trying to study paleoclimate. Paleoclimate means climate of the past, like Paleolithic rocks, old rocks. Paleoclimate means old climate. So he was trying to study old climates, and he found that the same area experienced different climates at different times. It means, suppose today India is experiencing what kind of climate? Tropical. Once India experienced temperate climate, and at other times India experienced polar climate. Because if you go to regions like Tamil Nadu, Karnataka, even Telangana, you will find that there are places where you have deposits made by glaciers, known as glacial deposits. And if you look at the present climate of South India, which is tropical because it is between the Tropic of Cancer and the equator, glacial deposits is an impossibility at the lower levels. At the higher levels, it's a possibility because if you go high, you can find glaciers, suppose at mountain tops, but at lower level, it is not possible. So Wegener says that the same area has experienced different climates at different times. So he asks, what is the reason for this? He says, this can be due to two reasons. First is that the area was there static and the climatic belts have shifted over it. When it was under tropical climate, it experienced tropical climate. When it was under temperate, it experienced temperate. And when it was under polar, it experienced polar. The other way is if the climatic belts are static. Now if you look at this, think of this. This is polar climatic belt, this temperate climatic belt, and this tropical climatic belt. So I'm saying if one area has experienced different climate, it means the polar climate was here once, the temperate climate was here once, and today the tropical climate is here. It means something like this. Suppose my right hand to be polar and left hand to be temperate, it goes like this. Once it was like this, then it happened like this, and imagine this to be again tropical, it happened like this. So it means the place was constant, but the climates have shifted. The other possibility is if the climatic belts are constant, the continent has drifted. It has come under the influence of different climatic belts at different times. He is a meteorologist and climatologist. A meteorologist is one who studies weather, and climatologist is one who studies climate. Difference between weather and climate is aggregate weather conditions observed over a huge length of time, generally taken as 30 years. Clear? Now, because he was a climatologist, he had very good idea about climate, and he says that the climatic belts cannot shift. Why they can't shift? He says because for climatic belts to shift, many things should change, like the distance between Earth and Sun, the axial inclination, the amount of solar energy emitted from the Sun's outer surface, etc., etc. And nothing of that has changed substantially in the geological past. So the climatic belts have remained constant. If the climatic belts have remained constant, then the continents must have drifted. And thus he came up with the continental drift theory. Do you understand this? Now, he made some assumptions. He made some assumptions because to give any theory, you have to take some assumptions. The assumptions taken by him are, the first assumption that he took is the Earth has a trispherical concentric structure. It means it is made out of three layers. The top layer, he said, is Sial, then is Sima, and then is Niphe. It means it's a density based layering or layered structure of the Earth. That is his first assumption. Second, he says Sial is limited only to the continents, whereas the ocean floor is made out of Sima. Because he says like this is the Earth's surface, and suppose this is Sial, Sima and Niphe. This is Niphe, this is Sima, and this is Sial. He says the surface is not actually like this. At places, the surface has elevations, mountains, and at places, the surface has depressions. If it has depressions and there is cloud and there is rainfall over it, you can understand it will soon get filled and will turn into an ocean if it's a huge scale depression. The ocean floor, this is the ocean floor, he says, is made out of Sima. Clear? Whereas the continents are made out of Sial. So first he says it's trispherical concentric structure because it's the common center, and continents are made out of Sial and oceans are made out of Sima. Second assumption. The third assumption that he makes, he says that Sial is floating over Sima, because the Sial, he says, is divided into different parts, and all these Sialic parts are actually nothing but continents. So continents are moving over the ocean floor. This is what he is saying. Can you understand this? The ocean floor is the ultimate surface and the continents are drifting over it. Are you clear with that? Now he says that to cause a drift means some sort of displacement, and by our knowledge in physics we understand that no displacement is possible without the application of force. So there must be some force. which is causing the displacement. Wegener says there are two of them actually. One is the pole fleeing force and the second one is the tidal force. The pole fleeing force, also known as the gravitational differential force. What does he say? He says that suppose, imagine that there is a boat which is in water. It experiences two kinds of forces. One is the force of gravity and the other one is the force of buoyancy. And both of them balance each out. Are you understanding this? If there is no buoyancy, only gravity, the ship will sink. If there is no gravity, only buoyancy, the ship will fly. But neither of that happens. Rather, the ship floats. Because if you have two forces, suppose this is F1 and this is F2, you can understand both are perpendicular to each other, then you would have a resultant which would go like this or like this. Can you understand this? These are resultant forces which are always at 90 degree to two forces if there are only two forces. Can you understand this? Did you understand this? So there is always a resultant force whenever there is two force. Imagine something like this. Suppose a man of my stature pushes this podium from that side and applies almost the same kind of force. Will I be able to push it on his side? Will he be able to push it on my side? But can we go like this? Do you understand this? It means this is the resultant of the application of the two forces. Simple physics. Now, look here. This is what he says, that as the ship floats because of these two forces resultant, similarly, as Sial is floating over Sima, it is also experiencing these two forces, the forces of gravity and buoyancy, and that's why it floats. Can I say that the flotation of the ship can be in any direction? Yes. Wegener assumes that it is towards the equator. It means continents are floating away from the poles towards the equator, and that's why he calls this as the pole fleeing force. Are you clear with that? Also known as flight from the poles. Clear? Now, Wegener makes a very important statement, and look here very carefully. He says that the Sial is floating over Sema very freely, or it's a free flotation. In physics, free flotation means very less friction or negligible friction. So it means like a hot knife in butter, very less frictional resistance. So it is moving very smoothly. So that is one reason why it is drifting. That's the first force. Second force, he says, that is the tidal force. And you know what is the tidal force? It is the gravitational force generated by the moon. And you understand that the earth rotates from west to east. And suppose, think of this, suppose India, suppose I tie it with a rope, a small thread suppose, and I hold one end of the thread in this finger, and imagine my finger top to be the moon, and imagine that thread to be the gravitational attraction of the moon. Now if I rotate the earth from west to east, what would happen to the Indian landmass? It would move to the west or to the east? To the west. Due to the tidal force, the continents are drifting towards the west, and due to the pole fleeing force, they are moving towards the equator. And what are the three assumptions? Sial is limited only to the continents, it is a trispherical concentric structure, and there is free flotation without any kind of friction. Do you understand this? Armed with all these things, Wegener proposes his continental drift theory. He says that until the Carboniferous period. Now Carboniferous period, for those who are not aware of it, is the time in geological past when the fossil fuels were formed. So until the Carboniferous period, all these continents were close to each other in the form of a supercontinent, and he called it Pangaea. The formation of Pangaea facilitated the existence of a huge ocean. He calls it Panthalassa. Now think of this. Think of this. Suppose I have a tub and I have water in it and I have marigold flowers. Do you understand that? Now suppose I drop 5 or 6 of them in a huge tub filled with water. All of them must be floating over the water. Now if I move the water like this, is there a possibility that all of them come together and join at one place? And that is Pangaea. Do you understand this? So this is what he says, that all the continents that come close to each other, they moved and formed a supercontinent which he says Pangea is German for supercontinent. As the supercontinent was formed, it facilitated the formation of a huge giant ocean. He calls it Panthalassa. This remained till Carboniferous period. But during the Carboniferous period, you can understand that if I move the water again, there's a great possibility that the flowers may separate. So the Pangea broke. Pangea broke into two parts. First, the northern part known as Laurasia or Angara land, and the southern part which is known as Gondwana land. Laurasia consisted of today's North America and Eurasia except India, the Indian plate, because that was part of Gondwana land. Gondwana land consists of South America, Africa, Madagascar, Peninsular India, Australia, New Zealand and Antarctica. Greenland obviously was a part of Angara land or Laurasia. Which was bigger? Laurasia was bigger. Definitely, because all the big countries, think of Russia, China, USA, was all in Laurasia. As you see, as Pangea broke into two parts, the northern and the southern, an arm of Panthalassa intruded in between. This arm became the Tethys Sea. Do you understand this? Now, like Pangea broke, Laurasia and Gondwana land also broke. The broken pieces, due to pole fling force, moved towards the equator and towards the west. As they moved towards the equator, they opened new oceans in the north and south, the Arctic and the Indian ocean, Arctic and the Indian Ocean. And as it moved towards the west, it opened a new ocean which is the Atlantic. And due to all of such movements, Panthalassa was severely restricted, and this restricted Panthalassa became Pacific. The Tethys was closed in time. The sediments of the Tethys were raised into Himalayas. A remnant of the Tethys remains, which is the Mediterranean Sea, says Wegener. Do you understand this? And Panthalassa was the oldest water body. So the floor of the Pacific must be the oldest. It is the oldest. You write one line. The floor of the Pacific is the oldest ocean floor. The floor of the Pacific is the oldest ocean floor. Now look here. This is what he says. It's 225 million years ago. It means Pangea remained like this. Then it broke. It moved towards the poles and towards the west. And this is the present arrangement. Herein lay the Tethys. A remnant of it remains in the form of Mediterranean today. You have the Atlantic, you have the Arctic, you have the Indian Ocean, and this restricted Panthalassa is your Pacific Ocean. Do you understand this? So this is Wegener's continental drift theory. And he says that this is because Sial is freely floating over Sima and continents are made out of Sial. This is also known as the Great Accident because he was a meteorologist and a climatologist who is coming up with a geomorphological theory. So usko to maza aa gaya. He said ki main aur bataunga. So he said that now I will explain how fold mountains are formed and how island arcs are formed. He says as the continents were moving, think of this, as the continents were moving due to the pole fleeing force towards the equator, this is the frontal edge, this is the rear edge. As it was moving towards the west, this is the frontal edge, this is the rear edge. You understand front and rear end? Now think of this. When it was moving like this, and can you understand that if suppose this is what happens. Suppose this is a sheet, and if I do this, suppose this is made out of say plastic and not paper, and if I push it against this, keep on pushing it, what would happen? There would come a time when its frontal edges would get crumbled and crushed, and if they get crumbled and crushed, they would get accumulated here in the form of a fold mountain. Are you clear with that? Because fold mountains are created due to compression. He says that as the continents were moving towards the equator, and towards the west their frontal edges got crushed and crumbled and mountains were formed. And this is how the Alps and the Himalayas were formed. The Alps and the Himalayas were formed because Laurasia and Gondwana were moving like this, and as towards they were moving towards the west, the Rockies and the Andes were the frontal edges. But he says that the rear edges could not keep pace with the entire continent because of difference in elasticity of the rocks. Now think of this. Suppose you are walking by holding a child in your hand and you're walking with great pace. The child will not be able to keep pace with you, and suddenly you will find that the child is left behind. This is what happens to the continents. As they move towards the equator, their rear edges could not keep pace. As they move towards the west, their rear edges could not keep pace. So equatorward movement created islands like Greenland, Antarctica, etc. And westward movement created islands like, say, Japan, Southeast Asia, Australia, or the Caribbean islands. It means Britain is a separated part of North America. Do you understand this? So Wegener presented all of this in a book called Die Entstehung der Kontinente and Ozean. It's a German name of his book, which he wrote in 1912. Clear? And finally it was translated to English in 1924. Do you understand this? Now, Wegener gave certain evidences in favor of his continental drift theory. And what are these evidences? First, he said that if you bring Africa and South America close to each other, they would fit with each other as if they are two pieces of the same whole. Do you understand this? This he called as the jigsaw fit. This is also known as the apparent affinity of the physical features. Clear? Second, he said that if you look at the distribution of rocks, say in North America and in Western Europe, you will find that the rocks are of the same kind. There is a mountain called Appalachian in North America and another mountain called Jolin in Western Europe. The rocks are of the same kind. It means once North America and Western Europe were joined, and these were parallel mountain ranges. Are you clear with that? That is another evidence. Third evidence is that in Brazil you have placer deposits. Placer deposits means gold deposits. And if you have gold deposits, it means you are looking for the geomorphic agent which brought the deposits and the source from where the deposits were brought. But if you look at modern day Brazil, you will not find such, suppose here are the deposits, you will not find the river nor the source of gold. The only major river is Amazon, and it has the orientation very different from the place where the placer deposits have been found. The answer lies across the Atlantic. If you look at Africa, you will find that when they were joined, there was a river, the river was River Niger, which brought in the deposits, and in Nigeria you have such gold deposits. So this is another proof that they were once joined. If you can join two, you are reconstructing Pangaea. If you can prove Pangaea existed, the theory is correct. Are you clear with that? Then he says that if you look at the fossil remains on both sides, say in Africa and in South America, they are of the same kind, of the same animals, of the same race. There is no racial diversity between them. It means, suppose there was an organism which was known as Mesosaurus. So it was a freshwater reptile. Now this Mesosaurus, its fossil remains have been found both in Africa and in South America. You say, if it is freshwater, can it swim across the Atlantic and reach at one place or the other continent? Further, it is very difficult to scale an ocean. Then the Mesosaurus will make some Olympic records if it does that. The other way is Mesosaurus flew and landed at the Atlantic, or it flew from South America and landed in Africa. And when you look at its shape and size, it's very difficult to understand that how the Mesosaurus can fly. It does not have any wings. Have you seen any reptile fly? Forget about the TV shows. But have you seen any reptile fly? Reptiles don't fly, as far as we know till now. Do you understand this? So Mesosaurus definitely could not fly. And this is possible only when they were joined and this entire area was Mesosaurus' domain. Do you understand this? And with time they got separated, so the fossils are found on both sides. This is not only true with Mesosaurus, but is also true with certain plant fossils. They are also found on either side. And definitely plants cannot migrate, for sure. Clear? Though their seeds can be taken away by the birds. But birds cannot fly. There is no bird which can cross the Atlantic. Only the Arctic fawn does it, or those which take long scale migration. And definitely you can say that the crane cannot be a pollinator of great benefit. Pollinators are generally small. Clear? Okay. Because if the crane sits over the flower is totally crushed. You understand? Now, this was the next evidence. Then he says that there are tellite deposits. Tellite deposits means till are actually glacial deposits. Glacial till means glacial clay. Clear? Now, in places like, I already told you, Tamil Nadu, Karnataka, Telangana, South Africa, you will have glacier deposits. But looking at their present climate, that is an impossibility. It means that once they were placed near the poles, and this is true. In fact, the city of Durban, have you heard about it? Was located at the South Pole once. And from there, it has moved towards the equator. Why? Because of the pole fleeing force, which is explained by Wegener. Then, there is also some behavioral evidences. Behavioral evidences means that in Western Europe, in the Scandinavia region, you have an organism which is known as lemmings. Now these lemmings, a typical behavior has been seen in the lemmings that whenever the population increases among the lemmings, they move to the west, jump into the Atlantic Ocean and commit suicide. Now this is very strange because Darwin says the entire effort is survival. First in pre, then in mains and then in interview. This is what Darwin said once. So he says that the entire aim is survival, and this is contrary to evolution. And how is this possible? This is possible because once the forefathers of the lemmings used to migrate toward the west. Lemmings are small creatures like rats, and on the east in Scandinavia there is the Ural Mountains. It is very difficult for rats to scale a mountain. So that's why they moved towards the west. And once there was continuous land beyond it. But now because of lack of land, and you can understand rats running all around. So the first row has no idea what is going on behind, and the last one who is running have no idea that there is no land beyond. But because of the pushing, you can understand all of them fall. They are not jumping into the ocean and committing suicide, rather they are being pushed into the ocean and they are being murdered by their own kin. Do you understand this? It is almost like homicide that is being conducted by the lemmings on the lemmings, not for the lemmings. Maybe the last row survives. Do you understand this? This is what happens. So that's also a kind of evidence in favor of continental drift theory. Pole wandering. Pole wandering means that the continents have not only moved to different areas, but the poles, like today I say that the South Pole is located in Antarctica. Once it was located in Durban. That is nothing but the poles have been wandering. There is also another wandering of the pole, but that is the magnetic pole wandering, which is not very important here as far as GS and that to pre is concerned. So this is the continental drift theory, wherein he gave so many evidences in favor of the drift and the formation of Pangea. His work was translated into English and was brought to Anglo-America, where it was hammered down, it was thrown and called a garbage. Why? The Americans said that he commits some basic mistakes. First, he says that the Sial is freely floating over Sima. But later he contradicts. He says that the frontal ends got crushed and crumbled and the mountains were formed. Crushing and crumbling requires friction or not? Yes. And he has already assumed that there is no friction. So Wegener contradicts himself, right, American scholars. Second, he says that Say for example, he says that the tidal force which is causing the continents to drag to the west is not enough to pull continents. Because of the moon's attraction, are you going like this to the west? So the moon cannot pull you, forget about the continents. How can it pull the continents? Wegener says, or the American rather said, that if Wegener says that the tidal force has pulled the continents, the tidal force must be at least 10,000 times stronger than what it is today. And imagine, remember the thread example? And imagine if I hold the thread very hard, will I stop the rotation of the earth? Such a strong tidal force would have stopped the rotation of the earth. And if the earth would have stopped at any point, then half of the earth would be a ball of fire and half of it would be a icy cold. Because it would be perennial night and perennial day. That is not the time. That has never happened. Do you understand this? So he says, or the American scholar says that the tidal force cannot pull continents. For God's sake, stop fooling us. And third, he says that the pole fleeing force has caused all the continents to move towards the equator. If that has been the case and the movement is always towards the equator, we would have got an equator-ward crowding of the continents. But today 90% of the landmass lie north of the equator. Can you see that? It means they have crossed the equator. So the assumption is not very appropriate. And thus Alfred Wegener's work was thrown away. Do you understand this? That was continental drift theory. Now, let us move to this, geomagnetism and paleomagnetism. Now, look here, it's just an adjunct to your continental drift theory. Are you aware that the earth has different layers like the crust, mantle, outer core, inner core? The outer core is made out of liquid and the inner core is made out of solid. Now, the outer core, it has nickel and iron in molten form. Can I say this? If it is liquid, nickel and iron in molten form because it is made out of Nephe. As the earth spins, this nickel and iron also moves. Can you understand this? It's like ऐसा हुआ बचपन में कभी बहुत पानी पी के दौड़ा होगा. So how did the water jump in your tummy? So as the earth spins, in earth's tummy, which is the outer core, the nickel and iron keeps on jumping and it also rotates. As it rotates, you can understand that the nickel and iron pieces or the nickel pieces or the iron pieces, they collide with each other. As they collide with each other, do they generate friction related heat? And whenever there is heat, there is charge. Have you done this experiment when you rub a scale on a sweater and you put like this and there is some charge created? Why? Because heat always generates charge. So think of this, that in the outer core, this is what has happened, that there are some charge areas created, and charges are of two types, positive and negative. Suppose in one part of the outer core there is aggregation of positive charge. It doesn't mean that there is no negative charge, but the area has more positive. So can I say this is net positive? Similarly, there are areas where you have more negative charges, but there can be some positive, but this is net negative. And the moment you have positive negative charge, you have a charge gradient. And if you have a charge gradient, what do you have? You have electric current. And if you have electric current, by left hand rule we understand, and the right hand rule we understand that there will be magnetic field and force perpendicular to it. Also, have you heard about the thumb rule? Yes, if suppose this is an electric, or this is a wire and this is the direction in which electric current is moving. So this is very foolish, but assume that I'm trying to do this. Clear? And my thumb indicates the direction in which the current is flowing. Then the magnetic field would be the way in which my fingers are rolling around. It is always perpendicular. Do you understand this? If suppose the current is like this and I hold it like this, then the magnetic field goes like this. Can you understand this? In the interior of the earth, since there is an electric current, there generates a magnetic flux. Do you understand this? Can I say that this magnetic flux, it cages the earth, and you can see that. If you are approaching the earth from outer space, first you will encounter the magnetic flux, then you will encounter the earth's atmosphere, and then you will encounter the earth's surface. Are you clear with that? The magnetic field has a wider range than the earth's atmosphere. Write this. The magnetic field of the earth, has a wider range than the earth's atmosphere. Now look at this, that can you see that magnetic lines of forces are emanating from the south, they're curling into the space and going into the north, and all of them emanate from one point and they go like this. Can you see that? Yes? Now the point from where they leave ground is known as the magnetic south pole, and the point from where they enter ground is the magnetic north pole. And if you have two poles and you join them, you have a magnetic axis. And if you have a bar magnet, it's almost like a bar magnet where you have a magnetic north pole and a magnetic south pole. It is located where? In the center of the earth. And this is why earth is also at times known as, especially books of physics will write it, geocentric dipole, because it has two poles. Do you understand this? Now think of this, that if I keep a magnetic needle, suppose there is a magnetic needle, I pivot it to its center of gravity and fix it, suppose to a wooden plank. This is the magnetized north end. And if I rotate it, suppose this is on the surface, and if I rotate it, it will, magnetized north end will always stop at the magnetic north. Do you understand this? It will not stop at the geographic north, but only at the magnetic north. Have you seen a magnetic compass? You have north, south, east and west, and the magnetic north pole is like this, and the magnetized end, the needle always stops like this. Why? Because it is pointing at the magnetic north pole, whereas these north, east, south are your geographic north, south. And that's why as a child you felt that the compass is malfunctioned and you try to improve the reading, but it never happens. As you do this, as you push it on this side, it comes back like this. Why? Because the earth itself is a huge bar magnet that controls the orientation of all the other smaller ones. If you're not understanding what I'm trying to say, think of this. Suppose I have a paper, a good paper which can hold some object lying and flying in the air. In mid-air, suppose there is a paper, and suppose I have one tumbler in which I have a lot of bar magnets, small bar magnets, and this is what I'm doing. I'm taking those bar magnets and throwing them over the paper randomly. They will all fall in random fashion. The north-south will go in any direction. Do you understand this? Now this is what I am doing. Suppose it is hanging in mid-air. How does that happen? Just forget for the time period and just imagine that is happening. And suppose I'm taking a huge bar magnet of the size of a log, and I'm going underneath it like this. Suppose, and I keep it there beneath it. What would happen to these small magnets? They would all realign as per this huge bar magnet. Since Earth itself is a huge bar magnet, it controls the orientation of all the other smaller ones. Do you understand this? The magnetic north pole today is located in the Bathurst Islands, which is in Canada, and the magnetic south pole is located in Victoria Land, which is in Antarctica. Write these two sentences. The magnetic north pole is today located at the Bathurst Islands. Bathurst Islands in the Queen Elizabeth group of islands in Canada, northern Canada. In Queen Elizabeth group of islands in northern Canada, put a semicolon. The magnetic south pole is located in Victoria Land. Where is it? Antarctica. Okay, there is Victoria, which is in Australia. So this is Victoria Land, located in Antarctica. Now, look at this, that this collision which is happening in the outer core, is it very organized or random? If it is random, the formation of charge provinces are also random. The generation of electric current is also random. So the electric current can flow in any direction. Do you understand this? If this flows in any direction, then can you imagine that the magnetic field will also move with it? Clear? So the magnetic field is not like this always, it can also move like this. It means it is never static but always in a state of change. It is true with all magnetic fields, and that's why we call them flux. Magnetic flux, which is never static but it keeps on changing with time. Now as it moves, you can understand the magnetic north pole can shift. There can be a chance that the entire poles, they replace each other. It means the magnetic north pole moves to the magnetic south pole's position and magnetic south poles move to the magnetic north pole's position. This is known as reverse polarity. Earth's history is a history of normal polarity and reverse polarity. In simple words, during normal polarity, the magnetized end points towards the northern hemisphere or in the north, whereas during reverse polarity, it points towards the southern hemisphere. Why? Because it is not pointing north and south, it is following the magnetic north pole, which is moving. This movement of the magnetic north pole is known as magnetic north pole wandering. Do you understand this? So you write one line. Magnetic north pole wandering. Magnetic north pole wandering is the movement of the magnetic north pole over the surface of the earth. Where is the north pole located today? Magnetic north pole? Bathurst Island. Once it was located in Siberia. From there it moved to Hawaii, and from there it has moved to this location. So you write another line. Once it was located in Siberia. Once it was located in Siberia. From there it moved to Hawaii to its present location. From there it moved to Hawaii, put a comma, to its present location in Bathurst. To its present location in Bathurst. B-A-T-H, Bath, Rust, R-U-S-T. Now, look here. These magnetic lines of forces, imagine like this, these magnetic lines of forces that emanate from the south, loop into the space and re-enter ground from the north. This is how the magnetic flux is. And a magnetic needle always follows these imaginary lines of magnetic forces. Do you understand this? And so, if you bring them very close to the equator, they go like this. But as you move them towards the poles, they become more and more steep because they are following the lines. Can you understand this? At the magnetic north pole, they become 90 degree into the ground. At the magnetic south pole, they become 90 degree out of the ground. For those who are not understanding it, look here. Think of this. Suppose this is the earth and I have a bar magnet. Suppose this is a tangent drawn to the earth. The angle is almost 0 degree or 180 degree. But if I am here, it goes like this. The angle becomes 45 maybe. If I am more closer to the poles, magnetic north pole I am saying, it goes like this, 90 degree. Similarly, in the magnetic south pole, it goes like this, out of the ground, which is again 90 degree. Can you understand this? This property is known as magnetic declination. This is at 0 degree magnetic declination. All those places, can you understand, these places will have dip of 0 degree, whereas as you move towards the poles it becomes steeper and steeper. As you move towards the poles it becomes steeper and steeper. Near the equator it has 0 degree dip. Now look at this, that suppose this is the earth and this is your geographic north pole, geographic south pole, this is the geographic axis and this is the geographic equator. this is the magnetic north pole, this is the magnetic south pole, this is the magnetic axis, you can understand that there would be one place where all the places, there would be at this point, imagine at this point, all the places will have 0 degree dip. This is known as magnetic equator. Clear? Now, see, magnetic equator is different from the geographical equator, and the magnetic axis is different from the geographical axis. The angle between magnetic axis and geographic axis is known as magnetic declination. Clear? Whereas this one is known as magnetic inclination, and magnetic equator is an imaginary line joining places that have 0 degree magnetic dip. Let's write these lines. First line you write, magnetic declination is the angle between, magnetic declination is the angle between the geographical axis and the magnetic axis. The geographical axis and the magnetic axis. Magnetic inclination or dip, magnetic inclination or dip is the angle between a freely suspended bar magnet and a tangent drawn, freely suspended bar magnet and a tangent drawn to the surface of the earth, tangent drawn to the surface of the earth. Magnetic equator is an imaginary line. Magnetic equator is an imaginary line joining all places that have 0 degree magnetic dip. 0 degree magnetic dip. For pre-purposes, this is enough as far as geomagnetism is concerned. What is paleomagnetism? Paleomagnetism means the study of magnetic properties as contained in old rocks. Do you understand this? So you write, paleomagnetism is the study of magnetic properties as contained in old rocks. Now, look here. Can you see the sun? And the sun is generating solar flares. As it generates solar flares, due to the magnetic field of the earth, they are pushed to the north and south. As they are pushed to the north and south, these solar flares, they interact with the magnetic field, and over the north pole and over the south pole, they make the sky glow. This is known as auroras, and there are two of them, aurora borealis and aurora australis. Borealis is a term in geography which means north. So borealis is over the north pole, and australis is a term which means south, like Australia. Clear? So it is over the south pole, and you can look at this. This is what I'm saying, that as the solar flares, they come in, due to the earth's magnetic field, they are pushed to the north and south. Can you understand this? And the sky glows over the north and the south. This is aurora borealis and this is aurora australis. Is it there in the handout? So you can write this. I'm giving you a minute. Write this. Or you can just make a diagram and write borealis and australis. That would be enough. This was asked in UPSC examination, in prelims examination. In previous years you can find it, say I think in 2013 or 12, it was asked. The names were not given, aurora borealis, australis, but the phenomena was asked, that the solar flares get diverted to the north and south because the rotation of the earth Earth's magnetic field, revolution of Earth around the sun, all of the above. So you can definitely understand कि जिसको लग रहा होगा इनमें से तो एक भी नहीं है, तो प्रिपरेशन में खोट है. Done? Okay. Let us now move to. Okay, you are not done with it? Okay, shall we? Okay. See, this is a rapid kind of thing that we are doing. We have to be at our toes all the time, otherwise we will not be able to complete the syllabus. Okay. Now look at this. Convective magma currents. What is convective magma current? What is convection? Like suppose if you boil water on a burner, suppose it's a glass tumbler in which you have put water and it's kept over a burner, you will see that the hot water rises like this. This movement is known as convection. If it is true with water, it is also true with magma. Can you understand this? So such a rising of the magma is known as convective magma currents, and it was given by Sir Arthur Holmes. Just write his name somewhere there in the convective magma currents. Sir Arthur Holmes, Holmes. Huh? Okay. See, is it written there? Okay, then good. Mat likho. Now, look at this. That this convective magma, as it rises, you can understand it hits the surface from beneath. As it keeps on hitting the surface from beneath, you can understand that it can destroy the surface because it is hot magma. Now think of this. Suppose I have a bucket and the bucket is filled with molten iron ore, and if I throw it against a wall, and if I keep on throwing molten iron ore towards the wall, and there would come a time that it would keep on eating the wall, and there would come a time that it would create a hole in the wall. As it creates a hole in the wall, the next time I throw, some of the magma will go through the wall, the rest will splash around the hole. Can you understand this? Very good. Now look here. Think of this, that this is what I'm saying. The convective magma is going like this. It is creating a hole. The moment there is hole, some of amount of it will be thrown, and this is nothing but volcanism, and the rest of it would move around like this. Now think of this, that suppose there is water and there is a ship in the water, and suppose this is what I do. I do not touch the ship, but I move the water like this on this direction. Will the ship also move in this direction? Can you understand this? Like suppose I do not touch you, but I move the tile over which you are sitting. Will you also move? Yes. So the ship moves because the water moves. Similarly, you can understand as the magma moves beneath it, the continents or the crust of the ocean floor moves. Do you understand this? And this phenomena is known as sea floor spreading. Are you clear with that? Now think of this. You know that the sea floor looks like this. You have continental shelf, slope, and the ocean floor. This is the mean sea level. You know the continents are made out of Shya, whereas the ocean is made out of Sima. And somewhere here, suppose the sea floor spreading is happening. You can understand that this creates a compressive stress at the Sial-Sima boundary. And when two things collide, and one is heavier and the other one is lighter, you know, lighter things rise and the heavier things sink. So the Sima, it sinks below the Sial, and as it sinks, it goes like this, deeper and deeper. It reaches a certain depth where the temperature and the pressure again rises exorbitantly, and it melts. And can you see that it completes a cycle like this? This is known as the conveyor belt. This was given by an American scholar, his name Harry Hess, who came up with the idea of sea floor spreading, and he took the help of Sir Arthur Holmes' convective magma current to explain it. Are you clear with that? Let us now look at the sea floor spreading. This is what I'm saying, that the rising magma, you can understand that it creates a crack, and from where the magma erupts. As the magma erupts, it cools, because as the magma erupts, it's hot magma, but it comes in contact with very cold water, because at the ocean floor you can understand that the water is dark and cold because sunlight cannot penetrate to that depth. So the moment it comes in contact with cold water, it freezes. It means it almost solidifies. As it solidifies, it forms a mountain. Are you clear with that? These mountains are known as volcanic mountains, and these volcanic mountains are also known as mountains of accumulation. Right, one line. Volcanic mountains are also known as mountains of accumulation. Volcanic mountains are also known as mountains of accumulation. Clear? And you see here, as the ocean floor is pushed against the continental crust, it subducts under it, and after reaching to a certain depth, it becomes part of the asthenosphere, which is the source of magma. Are you clear with that? This entire process is known as the conveyor belt. Now think of this. Look here. Think of this. Suppose there is a continental shelf, slope and ocean floor. Are there rivers over the continents? Rivers bring sediments, and you can understand sediments can be deposited here, and you can understand that with time these sediments may grow. Can you understand this? Now when the Sima subducts under Sial, it compresses the sediments. As it compresses the sediments, the fold mountains are formed. It means that all the fold mountains are formed out of deposits that were laid down on the ocean floor. Can I say so? Or all the fold mountains have marine origin and they are made out of sedimentary rocks. If they are made out of sedimentary rocks, suppose when the sediments were being deposited here, can I say that the ocean was lifeless? No, it might have had some life, and if it might have had some life, there might have been some fossil remains in these stones. Can you understand this? And so the fold mountains like Himalayas must have marine fossils. It is true. Himalayas have marine fossils because Himalayas are formed out of the sediments that were deposited over the Tethys floor or the Tethys geosyncline. Are you clear with that? Now, also you see one more thing, that sometimes some aspirants feel that it is the crust which folded and made the mountain. It is the sediments that have made the mountains. So all fold mountains, be it Rockies, Andes, Alps, Himalayas, all are formed out of sediments, and that's why they are sedimentary in their origin. Write one line. The fold mountains are formed due to the compressive forces which lifts the sediments deposited over ocean basins. Did you get it? Therefore, they all have marine fossils, or I can say one line, all fold mountains are conceived in the womb of the oceans. Write this line. All fold mountains are conceived in the womb of the oceans. All fold mountains are conceived in the womb of the oceans. Okay, so with this idea of seafloor spreading, again the interest in continental drift regenerated. That if they are moving, then definitely the continents must also be moving, because continents are also part of these lithospheric crusts. Now, look here. So there emerged the idea of plate tectonics. What is a plate? A plate is nothing but it is broken slabs of the lithosphere which are moving over asthenosphere. Wagner said that Sial is moving over Sima, but actually it is lithosphere which is moving over asthenosphere. The difference between lithosphere and Sial and Sima is lithosphere goes up to an average depth of 100 kilometers, whereas the continental crust's average depth is 60 kilometers. Are you understanding this? It means yes.
Can we say that for the formation of old mountain, river is compulsory?
Sediments are compulsory. Anything can bring the sediments, but rivers contribute. Yes?
What can be the other sources of sediment?
Glaciers, wind, but it will take a lot of time. Yes? Now, think of this, that the average depth of lithosphere is 100 kilometer, whereas the average depth of the crust is 60 kilometer. I am saying continental crust, and beyond it you have oceanic crust. It means lithosphere has both Sial as well as Sima, and below it lies the asthenosphere. Asthenosphere is pure Sima, and pure Sima is more denser than some impurities of Sima with Sial. It means the lithosphere is less dense than asthenosphere, and lithosphere is broken into different slabs. These broken slabs of the lithosphere are known as plates. The word plate for the first time was coined by Tuzo Wilson, a Canadian geophysicist. He coined the term plates. Now, you see that from the asthenosphere there are convective magma currents. So all these plates are moving with respect to each other. And the study of the movement of the plate and the consequences they bring is plate tectonics. Clear? Is it written there that the plates are broken lithospheric slabs? Is it written there? Okay, you write somewhere if it is not written. The plates are broken lithospheric slabs. The plates are broken lithospheric slabs that float over the dense asthenosphere. That float over the dense asthenosphere. Clear? Now you see, suppose these are two lithospheric slabs or plates. The movements can be only of three kinds. One is the plates moving towards each other, and this can happen at any angle. The plates moving away from each other, again this can happen at any angle. And third, the plates gliding past each other. This can also happen at any angle. When the plates move towards each other, they create compression. Whenever they move away from each other, they create tension. When they glide past each other, this kind of movement is known as transform movement. So you have normal fault, you have reverse fault, and you have transform faults. Do you understand this? And in the mid-Atlantic ridge, there is divergent plate boundary, which is causing volcanism and formation of the volcanic mountains, but there is also a transform fault. Let us see that. If you see, can you see a transform fault here? Clear? So if a statement comes in the examination that at the mid-Atlantic ridge there is a transform fault, it's a correct statement. Clear? You write somewhere, mid-Atlantic ridges have transform faults. Have transform faults. Okay, now let us come to plate tectonics. It says that thus the plates can move towards each other, away from each other, or glide past each other. So there are three kinds of movement: convergent, divergent, and conservative. It means where there is inconvergent, there is destruction of crust. We have seen that. Whenever there is convergence, there is destruction of crust. Whenever there is divergence, there is creation of crust, like at the mid-Atlantic ridges. And whenever there is movement like this, there is neither creation nor destruction. That's why we are calling it conservative. A plate can be either a continental plate or an oceanic plate. Depends upon what is dominating over it. Because plates are lithosphere, and you see lithosphere has both Sial and Sima. So you see, these are the 6 major plates, which are the Antarctica, North America, South America, Pacific, Indo-Austral, New Zealand plate, Africa, and Eurasia. These are the 6 major plates and these are the minor plates. Minor plates are smaller plates within the major plate. What we need to understand is how plate tectonics helps us understanding earthquakes, volcanism and orogenesis or mountain building. Now you see, suppose let us first take the convergent plate boundary. There is compressive stress. Can we understand this? There is compressive stress and we have already seen the mountain building. Can you understand this? If the earth keeps on moving like this, will there be shaking of the ground? So will there be earthquake? Yes. So you have earthquake. Now you see, as it goes like this, it hits it hard. And these are 2 huge land blocks which are hitting each other. Will they damage each other by creating some cracks? Yes. So it creates some cracks in the Sial as well. And if many of such cracks, they join each other and reach till the asthenosphere, magma gets a ready-made passage and comes out as volcanic eruption. That's why if you see the entire Pacific coastline is experiencing subduction of the oceanic crust beneath the continental crust, and you have mountains like Rockies and Andes. Pacific, to the east of Pacific, the earth is a sphere. So to the east of Pacific you have Rockies and Andes. You have also mountains in Japan. Yes. You have also mountains in China. And you have this entire area prone to volcanism. Is California prone to volcanism? Yes. Is Japan prone to volcanism? Have you heard about Mount Fujiyama? It is located in Japan. Have you heard about Mount Shasta? Mount Mayon? And these are all located in the circum-Pacific belt. This is known as the circum-Pacific ring of fire. Now you tell me, at the convergent plate boundary, does all the 3 events happen? Orogenesis, earthquakes and volcanism? Yes. At the divergent plate boundary, you know that when it diverges can form horst and graben topography. So there is orogenesis, block mountain means orogenesis. Is there earthquake? If the ground is slumping beneath you, will there be earthquake? Yes. And if this slumps like this, it can be possible that some magma may erupt out along the fault scarp. Can you understand this? So there is also possibility of volcanism. We cannot negate it. Are you clear with that? Many feel that the Malwa Plateau volcanism happened due to the slumping of the rift valley of Narmada. Some believe that it is the Deccan lava that has spill over to the Malwa region. So there are different thoughts on it. Okay, let us now go to the transform boundary. So at the convergent you have all the 3 events, at the divergent you have all the 3 events, and they are closely linked to each other. In 2014 also UPSC asked a question that there is a close association in mains. They asked GS paper 1, there is a close association between volcanism and earthquakes, and this was the reason they were just asking plate tectonics, put it differently. At the transform boundary you see the plates glide past each other. Will there be earthquake? Yes. Now if it goes like this, can you say that it can also dip like this? Will there be mountain building then? Yes, block mountain formed. And if it dips like this, can there be volcanism? Yes. The only one you can say outstanding example is in North America. In North America you see that the California minor plate is moving south-southeast, whereas the rest of the North American plate is moving north-northwest, and this entire boundary is a transform fault. Are you clear with that? And it has created 2 block mountains which are Sierra Nevada and Wasatch, which is in Utah, a province in United States of America. So you can have all the 3 events. Clear? Write one line. Plate tectonics helps us in understanding plate tectonics helps us in understanding all the 3 major events: earthquakes, volcanism, and mountain building. Always remember, Whenever it's convergent boundary, the mountain will be fold mountain. Divergent boundary, block mountain. लिख लो, convergent boundary equals to fold mountain. Convergent boundary equals to fold mountain. Divergent boundary equal to block mountain. See, it is already 12, but we will extend this class to 12:30. Why? Because today you do not have your tests. From tomorrow onwards, we will close at 12, and that's why we are adding more topics today, because we do not want to lose time. Okay, so let us look at this. This is the plate boundary, and you can see that they have shown it, the convergent plate boundary are shown with this symbol, the divergent plate boundary are shown with this symbol, and you have transform faults also in between. So this is the plate map of the world. Okay, now let us understand earthquakes. What are earthquakes? Earthquakes is nothing but the release of or sudden release of accumulated energy from the interior of the earth along the fault lines, which causes shaking of the earth. Earthquakes are the sudden release of the energy that has been accumulated over the years in the interior of the earth. Now think of this, like suppose if I try to bend this, with every force I am putting in energy into it, and this marker is accumulating all the energy in its potential form. But you can understand that there will come a time when I add more force, it will not be able to take it. And so what would happen? It would break and release all the force. Do you understand this? So the release of the force will be from the point where the wreckage takes place. Can you understand this? Similarly, earth accumulates energy due to its huge overlying load of the rocks. And this energy, there comes a time when it is released suddenly. And this release always takes place by creating ruptures, or if there is already a fault line, it's a weak zone, the energy can be easily released. Such release causes shaking, and this shaking is known as earthquake. Now you see, think of this, that the point from where the energy is released is known as the focus of the earthquake, and it is released in all directions. Clear? The point on the surface of the earth which is nearest to the focus is known as the epicenter of the earthquake. The damage is maximum at the epicenter. The energy that is released is in the form of seismic waves. Seismic waves are of two types, body waves and surface waves. Body waves are those which travel through the body of the earth. Surface waves which interact with the surface rocks. These body waves, when they interact with the surface rocks, they generate new set of waves which are known as surface waves. Body waves are of two types, P waves and S waves. Surface waves are of R waves and L waves. The P waves are known as primary waves because as they move, they cause compression and expansion in the direction of the wave propagation. And this is the property why they can move through solids, liquids as well as gases. Whereas the S waves, as they move, they create this kind of movement. It means the particles in the object move perpendicular to the direction of wave propagation. If you want to understand this, think of this. Suppose if the P waves pass through this duster will first squeeze and then it would expand as the wave pass along. But if the S wave pass, it would go hit the ceiling, will fall down as the wave cross by. Suppose this is made out of gas. If S waves moves like this, the gas will rise and there is no guarantee that it will return back. And that is the reason why S waves cannot move through gases. Suppose this is liquid, if the liquid goes splashes on the ceiling, there is again no guarantee that it will regain its shape. That's why it cannot pass through liquids and gases.